right, so what we're going to be doing here is looking at the graphs that we probably produced during our density labs and determining whether or not things would sink or float in water based on the way they graphed, and also being able to model those things and explain it. So first off, if we were to have graphed water, all right, the mass and the volume, all right, then the slope of these mass versus volume, all right, is the density. And that should kind of make sense, since slope is rise over run. All right, that's the slope. All right, and if we took the rise, that's the mass over the volume. Well, mass over volume is how you calculate the density. So the slope of those graphs is describing the density of the substances. In this case, one of the important things that you want to remember is that when considering water, plain water, all right, that its slope is 1 gram per milliliter. Or in other words, it has a density of 1 gram, right, per milliliter for water. Right. That's one thing that you guys will want to remember. Now, if we would have taken something else, for example, depending on which version of the density lab you did brass. Well, brass would have graphed something similar to, let's see here, let's say, yeah, right about there. This is brass. All right. And then, depending on what you did, if you did wood or on the virtual one, or the white block is of similar densities in the in-person lab, we'll do that in green. You would have gotten something down here. All right. Maybe something like this. Wood or the block, white block. So the question here is, what would happen if we were to place these two different substances in the water? Well, I'm sure you guys are perfectly aware that wood floats. Okay, wood floats, and brass, put in water, sinks. Well, a couple things that you want to realize is that anything down here, all right, below, all right, this is the float area of this graph, and anything up here, all right, this is the sink area. All right, why? All right, things that have a greater density than water. All right, so in other words, if the density, all right, is greater, all right, than 1 gram per milliliter of water, that means it sinks. Okay, but if it is less than 1 gram of milliliter, or 1 gram per milliliter, all right, that means it floats. All right. Wood down here has a much lower slope than 1, all right, something around 0.4-ish potentially. All right, in this case, about 1/2, the way I drew it. That would be an object that would definitely float in the water. The brass, on the other hand, has a slope of about 8, all right, and that would definitely sink because it has a greater density. So how would we potentially model this? So let's draw this out potentially. So for water. So H2O for water. I don't know, I could draw something kind of like this to model the density of the water. If I want to do the brass, right, over here, and over here I'll do the wood or the white block. All right. Again, this stuff needs to float, so it's going to have less density. And I can do that by a couple different ways, but drawing these particles smaller allows us to see that it has less mass in that same amount of volume, right, which would cause it to float. And if I want to do the brass, all right, something like this, those same number of particles, but those particles are much bigger, which means they're closer together in that same amount of space. So in other words, the compactness of the brass is higher, which causes it to have a higher density than water and would therefore sink. So this is the main thing that we wanted to go over today. So let's do a quick review. Water has a density of 1 gram per cubic centimeter, or 1 gram per milliliter, since cubic centimeters are the same thing as milliliters. Things that have a greater density, aka a higher slope in this case on this mass versus volume, that means it would sink. If it is below, in other words, a lower slope, that means a lower density, and it would float. And again, we've kind of already diagrammed this out, but just to connect those two ideas together, all right, wood, all right, represented here, is a lower density than the water, and the brass has a higher density than water.